All right, the next thing we're going to look at is flow length in terms of trying to calculate the flow path length. And so we have that previous flow accumulation grid. So we have those streams that were identified. And so what we can do is we have that flow grid, so essentially that stream network. And what we can do is we can then calculate from there the distance upstream or downstream a given pixel might be. So here's the flow length in terms of the geoprocessing search. Its definition says it calculates the upstream or downstream distance or weighted distance along the flow path for each cell. And so the cell indicates that, once again, we are working with a raster grid. And so in terms of our input, it's going to be that same flow direction grid that we've mentioned before. And it's the same flow direction grid we've used beforehand and the same DEM. So we get two outputs, and depending on what we want. And so we could have an output if we want the upstream option, or we have an output if we want the downstream option. In the upstream option, all it is the distance from a given cell to the origin of the longest path of water that reaches the cell from the upstream direction. And so our pour points are identified clearly here. And so think of this as, what is the distance to the origin of this flow? What is the distance to the top of the drainage basin, let's say? What is the distance to the higher elevations that contribute to the flow? And so what we have here is this particular pixel is going to be probably our highest value, shown in red here, and the other one is over here. And so these are going to be our two high values, and that makes sense. Those are our two pour points. So we have is the distance, and so think about that's the distance all the way. So it combines all the distance of all these cells that contribute to this particular flow. So each of these cells here then have different values based on how far they are in terms of downstream, let's say. And so values up here, there's not much flow. There's not much accumulation here. And so there's no accumulation and there's really no streams. There's nowhere to go up. Whereas over here, when we look at downstream, this is the inverse of that. So now we're going to see higher values are going to be shown up here at our higher elevations. So we see here in this particular case, this is saying that this particular area of the map, of the grid, is extremely far, is way far away from our downstream pour points. So here we have our flow length pane. We've got our flow direction 2 grid, our most up-to-date flow direction grid. Our output, we'll call it flow length up 1 because in this case we're doing a direction of measurement. We're choosing upstream. And this is where you can then change that to then make it downstream if you so choose. Go ahead and run it. And so what we did here was our Indianapolis DEM. This is the flow accumulation grid. So that's the flow grid that created this particular pattern here, the stream network that I can then click on. So I click on this. And so what this is this pixel value says 148,000. So that's just essentially the number that's created from the flow length in terms of upstream. So this is somewhere on the Near East side. And so this particular pixel, this particular, let's say, stream network, it's about halfway through from the top of the stream network all the way down to the downstream, in this case, down in the southern part of the county. Meanwhile, there in the southern part of the county where we have the White River essentially leaving the county, where it leaves the grid, we can see the pixel values higher, 221,000. So that makes sense because this is going to be our pour point for this particular grid in this particular area. So that previous pixel right here, essentially this is all going to eventually flow into this particular White River, and then eventually is going to leave the grid in this particular pattern here. And so now using the upstream method, this particular pixel, it's going to be the highest we're going to see anywhere along this particular flow because it's the last one, it's our pour point. And so it calculates everything upstream in terms of the distance, as we now have an idea as far as how far it is to get to the top of this particular drainage basin. And once again, this isn't so much distance in meters or feet, this is distance in terms of cells.